In this module, we are going for how to handle epidemiological data through R. Epidemiology is basically study about distribution and determinant for health related issues and taken further step to control those health related problems or issues. It is a broad area, and epidemiological study can be conducted qualitatively and quantitatively. Here in this module, we will see how to handle epidemiological data, the data considered as quantitatively, how to make statistical inference about epidemiological data, and with some related example. In epidemiology, generally we carry a specific study with specific disease, try to find out the disease frequency, distribution of disease, and try to find out the factors contributing for that disease in a specific populations. Disease of interest may be cardiac heart arrest, diabetes, cholesterol related problem, tuberculosis, polio, etc. Disease may be communicable, disease may be non-communicable. For communicable disease, there is a other way to handle data. For non-communicable disease, there is another study designed to handle data. But broadly useful or widely useful tool for epidemiological study data is generally rate, ratios, incidence rate, prevalence rate, point prevalence rate, relative risks, attributable risks. Those parameters we will see in others modules. We will not go into details in this module about these other parameters or indicators to handle the epidemiological data. In this module, we will see basic epidemiological data, how to incorporate data into R, and thereafter analysis part and the inference, statistical inference part we will see and illustrate. Here we will see how to obtain incidence rate ratio using epidemiological data. I will go for one example data. This is the importing the data set. Here first variable is assigned as E type, and E type is assigned as either 1 or 2, so it's a binary variable. So 1 and 2 has been assigned here for few individuals, and those individuals sex is decoded as 1 and 0, so a 1 standing for male and 0 standing for if they are female. Thereafter age of those individuals assigned as 32 years, 33 years, 35 years, like that. So here we are showing this importing the data to illustrate this data into the R, because there is another way to import the data into R by using the read.table functions directly from the hard disk, where your data saved as in text format or CSV format. But here we are not showing this because to be familiar with the variable in this data set. That is another options can be taken to import the data into R. When your data set is quite large, so it is advised to import the data from the hard disk, not to entering data like this and obtain the data dot frame. But for illustration purpose, we are using this. Now we go for next variable, that is given as RX. So those patients given which type of therapy is assigned here. So if they are given as standard therapy, so it's assigned as stand. If they are assigned as the metronomic therapy, so it's assigning as metro 2, and if they are assigning typical metronomic therapy, then it's assigning as metro. So here these RX having three possibilities: standard, metro 2 and metro. So now we'll find out the incidence rate between metro 2 with respect to standard and metro 1 with respect to standard, and incidence rate of these of individuals event will obtain from this data set. Now coming to the time, again time is observed into year, that is 3.34, 3.35, like all individuals having follow-up periods in years. So all these 5 variable assigned through a function called data.frame, and with e-type, sex, age, Rx and time assigned as a database with breast trial. So now we will call the breast trial, and after that we will see the data, and after that from this trial we will obtain the incidence rate. This example is obtained from a clinical trial example where we can find out the incidence rate, but the same kind of data can also be generated from the cross-sectional study design or observational study design. Now to get the example data set, we are putting the best trial of status as assigned E fails of breast trial, E type equals to 1011. Now we are coming to for fixed the Cox model here. So here we are applying the Cox model. So as you know that survival analysis can be done through the package called library survival. So to perform the Cox model, we are calling the library survival, and after that we are putting the function called Cox pH. Into that Cox pH, this functions SURV, and within parentheses time and status of those patient is considered with treatment Rx, and sex as a variable and age as a variable is considered here, as and database equals to base trial is considered. So these functions will give us the influence of treatment, influence of gender of the patients, and influence of age on their status respect to their follow-up time period. So this fit Cox model is useful to get the one kind of proportional regression modeling estimates. Now the Cox pH function is giving us the result, and as a result you can see the first column showing the Rx metro 2, Rx standard, and sex and age. So corresponding their regression coefficient estimate value are given in the second column. It's to be noted that since as a in the database we are having Rx as 3 arm, that is standard, metro and metro 2. So with respect to metro 2 regression coefficient is given as 0.57699. With respect to metro, again for the standard arm regression coefficient is given as 0.37694, and corresponding exponential of coefficients that is given as 1.78, and for standard it is given as 1.5646. So these 1.78 and 1.46 can be considered as odds ratio. So those patients treated with metro 2 in comparison to metro treatment, those are having 1.78% chance for more survival. However, it's to be noted that the regression coefficients observed is not significant, so p-value is also coming as 0.19. So it's quite high but significantly not high. Again for Rx treated with standard, they are also having quite high, but still it's not significantly high in comparison to metro arm. Now for the gender case, it's near to 1 regression coefficient, so whatever male and female both are having equal treatment effect with respect to their survival time, and for patient's age is having almost 1. So age is also, whatever the patient age is there is not any survival benefit on them that is obtained here. Now we will go for next slide to get the incidence rate using the Poisson model. with same term and log time as offset. So now we'll replace our time variable as log of time, and the same variable, that is status, will be considered as response here. And to run this, we will use the GLM functions here, and the GLMs within parenthesis status follows to offset log time with Rx, sex and age will be considered for the database called data equals to Bristol for with family Poisson distributions. So if we assign and if we call it as mode, when we call these results as mode, we are getting the result like coefficients for intercepts Rx metro, Rx10 and sex, and for intercept we are getting regression coefficients minus 3.00. For Rx metro we are getting 0.33, for Rx10 we are getting 0.206692, and for gender sex is coming minus 0.082543, and age is coming 0.0085, with degree of freedom 89 and 85 residuals, and residual deviance coming 87.56, and AIC value, that is ACI information criteria, is showing as 185.6. So ACI information criteria can be used to decide the model is suitable or not. So the model is having lower AIC value, the model is more fitted in that scenario. So by trial and error methods, the Rx, sex and age can be altered and can be replaced by other factor, and corresponding AIC value can be obtained. And that exercise we are not going to do here. We are going for to obtain the incidence rate of death among metro with corresponding to standard arm and metro 2 with comparison to. And now again get the rates using predicted functions. Now stand with the predict function is used for the summary of mod that we had given earlier, with data dot frame of time 1, Rs equals to stand, and age equals to mean of breast trial or with age, and sex equals to mean of breast trial sex, and type is equals to response is considered, and when you are calling the stand we will get the result. So it is to be noted that predicted value for stand is obtained here just by applying the predicted function, and within these parentheses mod is used here for time 1. Now we will see the results obtained for the standard predictions for standard arm, that is given as predicted mode with data frame, and is coming as 0.088065884. This is applying for the data set of breast trial. Here initially it is to be noted that we had considered age, sex and Rx on status of these patients. Now and assigning this mod, now mod is assigned with data with time equals to 1, Rx equals to stand, age equals to mean of breast trial age, and sex equals to mean of breast trial sex value. Now we are generating this predicted value for metro arms term. Again the predicted of mod data dot frame is used, time equals to 1 is considered, Rx is to metro is considered here, age of colon age is considered. It's a type of mistake, it should be breast trial of age, and sex equals to mean of breast trial of sex, and time is response. Then we will get the incidence for metro, and as a result we are getting incidence for metro with 0.0793061. Now we are getting the third predictions for metro 2, and metro 2 also we are using the same function predict. This is giving this incidence in the metro term arm with again mod data dot frame with time equals to 1, Rs equals to metro 2, and age equals to mean of breast trial of age is considered, with sex equals to mean of breast trial sex, and type equals to response is considered. When you are calling metro we are getting this value 0.10. Now simple results to calculate the incidence rate with respect to standard for metro and metro 2 with respect to standard, just metro divided by standard stand, and metro 2 divided by stand will give us the results for metro with stand is 0.90. so incidence rate ratio for metro arm is 90% or 0.9 with the limit with 0 to 1, and for metro 2 with respect to standard 1 is 1.14, that can be converted into percentage at 114%. So incidence rate, it can be concluded incidence rate in metro arm is quite less in comparison to standard arm, but metro 2 arm is quite high in comparison to standard arm. And metro arm incidence rate is 10% lesser than the standard arm, whereas metro 2 arm is having 14% more incidence rate in comparison to standard arm. So this way it is very easy to calculate the incidence rate from a trial data. The same type of incidence can also be obtained from epidemiological study. This we mentioned that epidemiological study can be conducted on case control study, cohort study, cross section, and for each kind of study design, if you can prepare the incidence separately for each arm and thereafter divide this corresponding incidence, we can get the incidence rate. Incidence rate is this value of one individual or one groups in comparison to others. So once we know the number of individuals is having effect in a specific group by dividing the number of individuals in that group, and in same way we can get the number of individuals affected in other group by dividing this total number of individuals in that group. So once we have group wise rate, and those rate can be divided, and we can get the incidence ratio between two groups as well. That is the implications of incidence rate, and this incidence rates give us the idea that one group is having higher rate of incidence in comparison to other group or not, and based on that epidemiological setup or planning can be conducted for further step. So this is the thing where we can calculate incidence rate using R. In this module we have seen how to handle epidemiological data using R. Here we have used the library survival to get the incidence rate. There are other way we can also obtain incidence rate from epidemiological data. From disease to disease, problem to problem, this incidence rate can be used to solve specific problem according to your research hypothesis. I hope you enjoyed this module, and definitely it will help you for further work on epidemiological data through R.